Alright, here we are a problem that will be using the idea of stationary waves and the patterns of stationary waves. So the setup is given like this. You have a loudspeaker producing sound of constant frequency, and you are place it near an open end of pipe. Okay, but there's a piston moving slowly towards the left. Okay, then they mention here that you hear a much louder sound when the value of x is 4.5 cm. The value of x started at 0. Okay, so assume that there is an antinode of a stationary wave at the open end of the pipe. Determine the frequency of the sound in the pipe. So you want to find out first, okay, what is the frequency of the wavelength that you'll be hearing if the x is at 4.5 cm. Given that this is the first loud sound that you hear, most likely that is the first harmonic. Okay. And they mentioned as well that at the open end, there would be an antinode. So I would assume that this would look something like this. This is the first pattern that you'll have. Given that that's your first pattern, and given this is an open and closed end type of pipe, then we say that lambda would be 4 times the length of the first harmonic value. Okay? So that means lambda would now be equal to 4 multiplied by 4.5 times 10 to the negative 2. Okay, let's compute that. 4 times 4.5 times 10 to the negative 2. You will get 0.18 meters. This is now the wavelength of your uh, wave. Now, how are we going to compute for its frequency? Use the wave equation. V is equals to lambda f. F is equals to V over lambda. Now, the V here is given as 340, so that gives you F equals to 340 all over 0.80. 340 divided by the answer, you will get now a frequency of 1,889 hertz. Okay, that's how you answer that first part. Now, it says here, after a time interval, a second much louder sound is heard. Calculate the time interval between the first louder sound and the second louder sound being heard. All right, in order for us to solve now this question, you just need to deal with first um, what would be the wavelength of that louder sound. So most likely that louder sound will be given at the value of wavelength, or the wavelength would be equal to current value of wavelength divided by 2. So that gives you 0.09 meters. Then from there, solve for its time interval using the basic equation of speed equals the distance over time. That gives you time equals to distance over the speed. So that's 0.09. The speed is 0.75 cm per second, right? So that gives you 0.75 times 10 to the negative 2 meter per second. Okay, so divide these two values. 0.09 divided by 0.75 times 10 to the negative 2. You will get a time interval of a good 12 seconds. That's how you answer this question.